The all-important Heine-Borel theorem in real analysis says that a subset of R is compact if and only if it is closed and bounded. If you saw our video on real induction, you'll be able to prove the difficult direction in just a few lines. So check out that video if you're not familiar with the technique. So we'll show that the closed bounded interval a to b is compact. You can generalize this to all closed bounded subsets of R without too much trouble. Now take any open covering of a to b. We need to show there is a finite subcovering. Let S be the set of all x in the interval a to b such that there is a finite subcovering of the closed interval from a to x. For the base case, we have to show A is a member of S, but that just means there's a finite subcovering of the single point A. We know that A must be contained in one of those open sets, so A is definitely in S. For the extension case, we assume the closed interval from A to X is a subset of S. Now we know that X is in one of those open sets that we're including, call it U. Since U is open, there must be an epsilon ball around X that's contained in U. So just pick delta less than epsilon, and we see that our subcovering already takes care of this new extended interval A to X plus delta. For the closure case, we assume that the half-open interval from A up to but not including X is a subset of S. Now, one of those sets from our original open covering must have contained X. So add that open set to our finite subcovering, and voila, we have a finite subcovering of the closed interval from A to X. Therefore, the entire closed interval from A to B has a finite subcover. With a little work, you can extend this argument to work for any closed bounded subset of R. How would you do it? Leave your answer in the comments.